Yo, what's going on, class? Back here. So I actually wanted to teach you guys about this problem number 3 that is on the Newton's Laws homework review worksheet. This is the assignment I passed out today during the half day. I said it's going to be due on Monday. All right, so I want to go over this problem and teach you the strategies to solve this problem. So first thing first, we have mass 3, which is the hanging mass. All right, we have mass 1. We're going to call this one mass 1. This was mass 2, and this would be mass 3. All right. So mass 1 is the 4 kilograms, mass 2 is 6 kilograms, mass 3 is going to be the 10 kilograms because it's 98 newtons. That's the weight of it. So 98 divided by 9.8 gives us 10. So mass 3 is 10. So we have those three things. All right, so now we're going to do the free body diagram for each one. So there is friction in this. So we have the free body diagram for this one is going to be force of gravity, 1, normal force, force of tension, force of friction, kinetic. All right. For mass 2, it's going to be force of gravity, 2, normal force, force of tension again. So we'll call this one 1, tension 1, and tension 2. And we also have force of friction kinetic here. All right. We can call this one force of kinetic 1. You can call this one force of kinetic 2, whatever you want to call it. And then the hanging mass, we have just force of gravity and force of tension 2. All right. So I know that's a pretty bad sketch, but I think you get the idea. All right. All right. So from here, what we know is that force of gravity 3 here, all right, is going to be pulling down this system of masses, right? So force of gravity 3 is like the root cause of the acceleration of all three of those masses, all right? So we're going to go ahead and I'm going to go ahead and solve for the acceleration, the tension, the force of friction. So the first thing I'm going to do is calculate the force of friction for each mass. So the force of friction kinetic is equal to the coefficient of kinetic friction times the normal force, right? So the force of friction kinetic for the first one is going to equal to the 0.35 times the normal force, which is going to be 39.2 here, 39.2. All right, so that's the weight of mass 1, the force of gravity of mass 1. And then that gives you the force of friction kinetic, 1 of 13.7 newtons, okay? So that's the first thing. That's the force of friction kinetic of the first one, all right? Now, the force of friction kinetic of the second one is going to be the force of friction kinetic of 2 is going to equal to the coefficient of kinetic friction times normal force 2. All right. So the force of friction kinetic is going to equal to 0.35 times the weight of 2, which is going to be 58.8 newtons. All right. And then the force of friction kinetic 2 is going to equal to 20.6 newtons. Okay. So that's force of friction kinetic 2. All right, now, you have those forces of frictions. You know weight 3. Now we can actually go ahead and solve for the acceleration. So what we know is that Newton's second law states that F net equals ma. Now, what you're going to do here is you're going to look at the system, right? The entire system moving as one cohesive thing. So it's the total mass of the system that is moving, that is accelerating. So the net force that is affecting that system is going to be force of gravity 3, right? Because the whole system wouldn't even move if force of gravity 3 wasn't there, right? Minus the force of friction kinetic 1 minus force of friction kinetic 2, right? And that's going to equal to MA, all right? MA, okay? All right, so that's an A over here, MA, okay? So the tensions is an internal force. What that means is that you have the tension here for 1 is pulling mass 1 to the right. But for mass 2, tension 1 is pulling it to the left. So it kind of cancels out, right? The same thing happens for tension 2. Tension 2 is pulling mass 1 or mass 2 to the right, but it's also holding back mass 3. So again, those kind of cancel out in the system, right? They affect individual masses, right? But they don't actually affect the system moving itself, right? So we know force of gravity 3, we know force of friction kinetic 1, we know force of friction kinetic 2, we know all the masses. The only thing we don't know is A. So acceleration is going to equal to force of gravity 3, which is going to be 98 newtons, minus the force of friction, which is of 1, which is 13.7 newtons, minus the force of friction of 2, which is 20.6 newtons, divided by the total mass of the system, which is going to be 4 plus 6 plus 10, the total mass of that system. All right? And then A is going to equal to 3.2 meters per second squared. All right? Now, that is the acceleration of the system. So you have to keep in mind that the tension doesn't affect it. The force of friction is in the opposite direction of the acceleration of the objects. That's why you are subtracting them, right? Because both mass 1, mass 2 want to go right. The force of friction is in the opposite direction. So keep that in mind. Force of gravity 3, that's in the same direction as the acceleration, so that stays positive, all right? And then you have the total mass of the system because the whole mass is moving together as one thing. And then you get an acceleration of 3.2 meters per second squared. All right, the next thing we have to do is we are going to solve for tension. All right, solve for tension. All right. Now, the tension is a little bit tricky, but what you do is you isolate one mass at a time. All right, so if I want to figure out, I guess in this question, it really is only looking for one tension. So if you look here, it's asking for tension, and I guess we're assuming it's just that one tension. So you can do it one of two ways. You can isolate mass 2, all right? Actually, that's a little bit tricky. Actually, you can't really isolate mass 2 because you don't know this tension or tension 2, or tension 1 or tension 2. You could isolate actually this whole thing together, right? These two together and treat it as like they're moving together. You could isolate, or you could isolate the hanging mass. Now, I like the hanging mass. The reason why is because if you look back, the free body diagram was just force of gravity 3 and tension, right? That's it. Those are the only two forces affecting mass 3's acceleration by itself, all right? So if you were to, when you look at the Newton's second law equation for that, it comes out like this. So you have F net equals M3A. Now, I like to call it M3A because that allows me to know that I'm only looking at mass 3. Like, what are the forces acting on mass 3? That's it. So the forces acting on mass 3 are force of gravity 3. Now, tension is in the opposite direction of that, and it's in the opposite direction of the acceleration. So minus the force of tension is equal to M3A. Right? So we know everything. We know force of gravity 3. We know M3. We know A. We know all that stuff. So the tension is going to actually equal to the force of gravity 3 minus M3A. All right? And that will give us our tension. Okay? So let's solve that out. All right, so we have force of gravity 3, or Ft, is equal to 98 minus M3, which is 10, times our acceleration, which is 3.2. All right, 3.2. All right, now that means Ft comes out to be 66.1 newtons. And that is your tension. That's it. All right, so acceleration came out to be 3.2, and your tension came out to be 66.1 newtons. There are other ways to do this. All right, many different ways to do this. I do want to show you them. So let's see another way to solve for tension. All right, so the other way to solve for tension is if I isolate this system of masses. All right, this system of masses. Okay, so we have these two masses are being pulled to the right by tension. All right, so the equation for this one would look something like this. We would have F net equals M1, 2A. So that tells me I'm only looking at mass 1 and 2. I'm ignoring mass 3. All right, so the F net in this situation is going to be Ft minus force of friction kinetic 1 minus force of friction kinetic 2 is equal to MA. I'm running out of room. All right, you get the idea. So these forces make up the net force. All right, so it looks very similar to when we originally solved for acceleration, but this time we know the acceleration. All right, so let's solve for Ft. So Ft is going to equal to M1 plus M2, which is going to be 10, times 3.2, right, plus the total amount of friction, right? So the total amount of friction, which is going to be plus 13.7 plus the 20.6, the two different frictions that we got, right? So we add those together, and guess what Ft equals? 66.1 newtons. All right? The same exact answer that we got in the previous way of solving for tension.